Welcome to This Explainer. Today, we're taking abstract coding concepts and turning them into a highly practical toolkit by learning how to actually have a real conversation with your computer. If you've ever felt like programming is just, well, typing cryptic commands into a void, get ready to completely change your perspective. We're looking at Python today, which is an incredibly powerful language beloved precisely because it reads so much like plain English. By the end of our time together, you won't just understand code. You'll know how to speak to the machine, teach it to reason, and gracefully fix the conversation when things inevitably get lost in translation. Here's our roadmap for the day. We're going to cover speaking and listening, math and logic, writing clean code, and finally, fixing common bugs. All right, let's jump straight into section 1, speaking and listening, specifically focusing on input and output. So, right off the bat, how do we actually make programs interactive? Because let's be real, a script isn't just a static document or a calculator that runs once and stops. To make something truly useful, we have to establish a continuous dialogue. We need the program to be able to ask a user for information, process that information, and then respond back with something meaningful. Without that loop, your code is essentially just talking to itself. And this flow really breaks down into a simple 3-step process. First, the user provides data using a built-in Python function called input. This is basically how the computer listens. Second, Python processes and stores that data in its memory. And third, it translates a response back to the human using the print function. User types, Python processes, screen displays. It's the absolute heartbeat of every interactive app you use every single day. Now, listen up, because this is probably the biggest beginner trap you're going to face when having these conversations. I want you to burn this critical rule into your memory. The input function always returns a string, period. Even if your user types the number 25, Python does not see the mathematical value 25. It just sees the text character 2 and the text character 5. If you try to do math with that, like, say, adding next year's age, your code is going to crash or give you a very weird result, because you're literally trying to do math with a word. So how do we get around that? Well, to actually do math with user input, we have to translate it first using type conversion functions. Think of these like translation lenses. If you need a whole number, like for an age or a game score, you wrap your input in int function. If you need a decimal number for a price or height, you use float. To force something to be text, use string, and for true or false checks, use bool function. Remembering to translate your inputs using these functions is the secret to unlocking actual interactive math in Python. Moving right along to section 2, math and logic, focusing on operators and expressions. This is where operators come in. These are symbols that act as instructions, telling Python to perform specific math calculations or logical comparisons. You know the standard ones like the plus sign for addition, but Python gives us some incredibly powerful specialized tools too. Take floor division, which is the double slash, that divides numbers but chops off the decimal, leaving just the whole number. Or the modulus, the percent sign, which gives you the remainder of a division. That one is super useful for figuring out if a number is even or odd. And then we have logical comparison operators, like the double equal sign for is equal to, or the exclamation point equals for is not equal to. These comparisons are vital because they always result in a true or false answer, which is exactly how your program makes choices based on the data. Let's actually see this in practice with assignment operators. These are essentially shortcuts. Instead of typing out score equals score plus 10, you can just type score plus equals 10. This lets us efficiently update variables on the fly. You start with a score of 0, add 10, multiply by 2, subtract 5. You're dynamically manipulating data in real time. And you can even use these operators on strings. If you multiply a word like Python by 2, it literally prints Python Python. It's a highly logical, yet wonderfully flexible system. All right, section 3, writing clean code. We're talking comments and code readability. Programming isn't just about giving instructions to a machine. It's heavily about communicating with other humans. This quote really hits the nail on the head. Code is read far more often than it is written. You might bang out a script in an hour, but you, your teammates, or even just future you will spend dozens of hours reading it months down the line. We have to leave sticky notes, called comments, throughout our files. You use a hash symbol for a single-line note or triple quotes for multi-line notes. Python completely ignores these, but the humans reading your code absolutely rely on them to understand your thought process. To make sure everyone understands your code effortlessly, you really want to adopt the official Python readability rules known as the PEP8 standard right from day one. This means doing things like using descriptive variable names. Call it student_age, not just the letter A. Keep it to one statement per line so things aren't cramped. Use blank lines to visually separate logical chunks, and always use a consistent 4-space indentation.
But honestly, the golden rule here is add comments explaining the why behind your code, not just the what. Don't write a comment saying, this adds 2 numbers, if the code already shows us that. Instead, write, calculating the user's total score to determine if they pass. Context is absolutely everything.
Which brings us to our final section, Section 4, Fixing Common Bugs, Errors, and Debugging. Look, bugs happen. A bug is simply an error in your code causing unexpected behavior. When Python hits one, it stops and hands you a traceback. Now, a lot of beginners panic here, but instead of seeing errors as failures, you have to realize that a traceback is basically just the computer politely asking for clarification. Since the machine has zero common sense, it literally hands you a report with the exact file, the exact line number, and a specific error message pointing right at where it got lost. It's not yelling at you, it's giving you a treasure map to fix your typo. You're going to run into these 4 specific misunderstandings all the time. A syntax error usually just means a typo, like a missing parenthesis or forgotten colon. A name error means you're trying to use a variable that hasn't been defined yet, often because you just spelled it differently earlier on. A type error happens when you mix incompatible data types, like trying to add text directly to a number. And a zero division error is exactly what it sounds like. You accidentally tried to divide by 0, breaking the laws of mathematics. These are a completely normal part of the coding process. For instance, say you run your script and boom, Python throws a name error. What does that actually mean? It means the variable is not defined. Maybe you named your variable message with 2 S's, but later tried to print it with 1 S. Python has no idea they're supposed to be the same thing. But the fix is easy. Read the traceback, correct the typo, and restore the dialog. And honestly, that is how you start talking to machines. We have covered a tremendous amount of ground today. You now know how to take inputs and give outputs, how to use operators to process logic, how to write clean code using PEP 8 standards, and how to confidently read tracebacks to fix bugs. You have the foundational toolkit. So the only question left for you is, what interactive project are you going to build first? Thanks for joining me on this explainer, and happy coding!